Hello friend. When I was giving interviews, then first I face rejection in interviews and then I get the important questions from the interview. But why to face rejections if we already have the important questions? So today I'm going to share you the top 25 most asked AWS interview questions. If you are new to AWS, then don't worry. I will explain each question step by step like this, with simple diagram and definition, so that you will understand everything. And if you are experienced in AWS, then just sit back, watch and revise your answers completely. Maybe you are missing some important information, right? By the end of this video, you will be able to answer most of the questions in your AWS interviews, because these are the most important and common questions asked in AWS interviews. So, what are we waiting for? Let's start with the first question. What is cloud computing? What is AWS? By the end, you will feel 100% confident on both of these concepts. Imagine you have developed one application which is live on production, and this user is accessing your application right now. Your user will type the URL in the browser, and through the internet, the request hits your front-end application server, which can be in Angular, React or JavaScript. This front-end server then passes the request to your back-end server application, which might be in .NET, Java or Node. Now, if any data is required, the backend will request to the database server and finally send the response back to the user, right? And yes, sometimes this front end and this API server or API backend are same thing. API server can be the single one server, which can be the monolithic application also. Okay, so this is how your own premises infrastructure is set up. Okay, this is on-premise application. On-premise means that your company has to purchase these servers and maintain these servers physically inside their own office or own data center. Okay, now listen carefully. Instead of maintaining these servers physically inside your company, the other option is your company can use the cloud computing platforms like AWS, Azure, Google Cloud, etc. In cloud platforms, all the servers and the database and many more services are already present. Your company has to just use them through the internet. Okay. For example, to host a web application like this, you can replace this physical servers with AWS EC2 instances like this. EC2 in short are just like physical servers only, and they can also host your application in the same way. So instead of maintaining this physical database here, you can use the AWS database, which is called RDS. Okay, AWS RDS, which is again the same RDBMS, but it is present in the AWS. Okay, I will explain this EC2 and RDS in upcoming questions in detail. So that's it. This is simple cloud computing, where your servers and database and many other services are present already in the cloud, in the AWS servers, and you just have to access them via internet. Okay, internet, remember. So cloud computing, remember, this is a concept, and Azure, AWS, Google Cloud are implementing those concepts. They are the practical implementation. So for example, in this case, AWS, EC2 and RDS are located in Amazon data centers across the world. Okay, inside the AWS cloud computing. And your company and many other companies can use these servers via internet connection by subscribing those services. So that's why now your company do not have to maintain physical servers. These physical servers not required, physical databases not required. Okay, just internet connection is required. So that's it. Now let's conclude. Easy to remember definition. What is cloud computing? Cloud computing is the delivery of computing service. It's a concept like servers, storage, databases, networking software, AI over the internet instead of using the physical hardware or local server. Clear? So I will explain all the storage, database, networking services, cloud in AWS in the upcoming question. Okay. Now, what is AWS? Here is the definition. AWS is a cloud computing platform provided by Amazon, offering a wide range of services for building, deploying, and managing applications and infrastructure. So you need not to worry about the infrastructure. AWS provides all the services related to infrastructure. You just have to use them via internet. And your company do not have to maintain physical on-premise server now. So this is one advantage of AWS, that your company do not have to maintain the servers. But there are many more advantages of AWS, and that's exactly what I will explain in the upcoming questions. The 5 advantages of using AWS which you must know. And in the upcoming questions, I will keep the diagram on the right side and the super simple definition on the left side, so that if you want to revise quickly later for your interviews, then it will be super easy to do that from this book also. And yes, many candidates have accepted my never give up challenge and got success in interviews. You can be the next one. Type never give up in comments to accept the challenge and share your success story when you make it. What are the 5 advantages of using AWS over the on-premise servers? Or you can say, why to use AWS at all? Now you are going to master this answer. Here is the same example where a user is accessing the front end and the back end applications from using in AWS. Okay. So first clear advantage is cost saving. Yes. For example, your company has now 10 applications, and to host them, they have purchased 10 physical servers. But tomorrow, if your company has only 5 applications, that means 5 purchased physical servers or system are waste. Only 5 you need. So rest 5 are waste for you, right? For your company. So, but AWS provide pay as you go model, meaning if you use the servers, then only you pay. If you don't need the remaining 5, you don't pay for that. Okay. Otherwise, you can just immediately remove this EC2 servers from your AWS account if you don't need it. No need to pay for anything which you are not using. No maintenance cost or for these physical servers. Amazon will take care of all the maintenance. Okay, so that is the top most first advantage, and the same thing is written here also. Second advantage is, suppose you are hosting an e-commerce application on your physical on-premise servers, and more website users are visiting your e-commerce application on weekends, Saturday, Sunday. The load will increase immediately, right? For that, why should you buy extra physical server just for the weekends? Okay, just use AWS Cloud, and there the servers or these EC2 instances will be automatically added when the load will increase automatically. Okay, that's possible. That is called auto scaling, and that concept is horizontal scaling. And so after on Sunday, these EC2 instances will be added. On Monday, load will be less. The EC2 instances will be automatically removed from your account. Okay, that's great. And I will explain these concepts in detail in upcoming question. But this is the advantage, and same thing is written here also. Auto scaling and flexibility automatically increases or decreases resources based on demand. Instant loads can be handled. Okay. Third advantage is high availability. Very simple. AWS offers 99.99% uptime with their service level agreement. They assure you, which means AWS guarantees you to keep your servers always on and available. Okay. Fourth advantage is disaster recovery. In case of any disaster, automated recovery and data backup will be provided by the AWS. Because your data is stored in multiple AWS data centers or availability zones, if one data center will fail, another data center will provide the backup. That is how it works. Whereas if you have the on-premise servers, you would need to manage the separate backup servers manually on your own, right? Finally, the fifth advantage is advanced security. AWS uses AI-driven threat detection, encryption, multi-layered security, which you don't have to even think about. They are providing it and you are just using it. You don't like IAM, access policy, multi-factor authentication. I will explain them in upcoming questions, but that is an advantage. Okay. So in short, you do not have to bothered about like security, hacking or malware. Okay. All right. I hope now you understand completely why we should use AWS cloud instead of the on-premise servers, right? Now, yes, in the upcoming questions, I will explain how to practically achieve all these features like the security, scalability, availability, how to achieve these in AWS in the upcoming questions. So be ready for it. What are the main cloud service models? Explain the difference between IaaS, PaaS and SaaS with AWS example. Now, maybe you have heard about this before, but today, after listening to the answer, you can explain this to anyone. Okay, let me give you my own example. So when I was a developer, I was 90% time focused on the application code and the database. But to manage one production application from start to end, many things are needed. To manage an application in your company, this full computing stack is required. Here are different layers. Okay, at the top, these developers are handling this application and data. This is managed by developers. Okay, then there is the IT or the infra team who do the bottom task like the runtime, like for example you install Java runtime, .NET framework on the server, Node.js frameworks, so that done by the IT team. Then your application might need some middleware like MS Office, some third party software your application need, MS Office, SAP or something else, some other API. Okay, below that OS like Windows server your application is hosted or the Linux server, so that IT team will install. Then virtualization is required to simulate the hardware. Okay, then physical servers, definitely where your application will be hosted, that physical server must be secured, updated and monitored, right? And IT team will also install the antivirus to secure your servers. Next we have the storage, because your application have some images, they have some files, some database, so some storage on the server is required. And finally the networking part. Networking on server is required to connect all the servers databases together. So this is the entire setup from runtime to networking, which is handled by the IT or the infrastructure team. So both developers and IT team work together for your company. Okay, meaning This fully on-premise setup is handled and managed by your company only, okay? And honestly, it's a lot of work. Now, AWS or any other cloud platform provides three major cloud service models to lighten and to make your work simpler, your company work. First model is IaaS, Infrastructure as a Service. In infrastructure, IaaS, application data runtime middleware OS will be managed by your company, okay? But virtualization, server, storage, networking will be managed by AWS. So your company work is less now, right? So basically infra or IT team has less work to do, right? Second most popular is platform as a service. This is the most popular cloud model, okay? Here your company mostly focused on application and data only, okay? Rest of the things, runtime, middleware, OS, networking, server, storage, so everything is managed by AWS, okay? Third model is software as a service, SaaS. And here everything is managed by AWS, including the application and the data, okay? Your company just have to subscribe and use this software. For example, if you have heard about Amazon Workmail or Salesforce or Office 365, these are SaaS platforms. Your company just uses these services as a user. Your company do not have to develop code or configure anything in the AWS. No technical work is required in SaaS, okay? So that is the simple story of IaaS, PaaS and SaaS. And now listen carefully. All these are just, we discussed this application, data, runtime. These are layers, not actual AWS services. Each layer includes some specific services. For example, there is a service Amazon EC2. It is the part of the servers, IaaS, okay? Server layer. So Amazon S3 or EBS are actual services and part of the storage layer, okay? So as a AWS developer, you will mostly working on the implementing AWS services, not the layers needed for the understanding, okay? And in the upcoming question we will focus on services, not layers, but I hope now layers are clear to you. And also you know that mostly you have to work, if you are a AWS developer, you have to work on IaaS or PaaS, because on-premise is completely different. It is physical servers, it's not cloud. And SaaS, AWS developer do not have to do anything. It's just a service which your company has to do directly. That's it, okay? Great. So that is the whole idea of these three cloud models. If it is clear to you, write crystal clear in the comments or chat box. That will boost your confidence and help you remember this forever. And yes, I have also added minimum definition and description of all the layers in this book, so that I already explained it, but yes, I have given it here in the book, so that if you later want to revise, then you can revise quickly from the book, okay? Again, don't try to memorize it, so it's not needed, but try to understand it, okay? Now here is a short question. What is the AWS shared responsibility model? I already explained this IaaS, PaaS, SaaS diagram in previous questions, and you already know that now in cloud your company have to do the minimum work. AWS will take care of many things, okay? So this division of responsibilities, some part will your company will do, some part will AWS will do, is the AWS shared responsibility model. Very simple, meaning your company is sharing some work responsibility with AWS, That's it. The same thing is written here. But now may you ask how your company can use and interact with the AWS services, and that I will explain in the upcoming question. Before moving forward, ask yourself just one thing. What is the point of learning AWS if you can't crack the AWS interviews? That's why I have created a complete AWS interview preparation bootcamp for you with 3 powerful tools. Number 3, 200 plus AWS interview questions from all the topics step by step. Even if you are AWS beginner, still you can learn everything here. Also, the real scenario based questions are covered. Then in this Smart Excel, you can mark questions prepared or not prepared, and therefore you can track your interview preparation progress like this. Second tool is this PDF book for quick revision just before your AWS interviews. And first tool is 10 AWS mock interviews to help you practice just like the real interviews. Many students have already cracked interviews with my courses. You can be the next. Remember, just one missed question can lead to interview rejection. Why take the chance then? Check out all the links in the description. If interested, great. If not, no worries. Let's move to the next question. What are the main categories of AWS services? What are the top 25 services? Now let me show you first AWS Management Console. Here it is. If you log in into AWS, then this is your AWS Cloud Console where you can use the AWS services. Here, if I will click this view all services of AWS, okay, see all these are like this compute, developer tools, machine, containers, storage, and many more. These are the categories, okay. And now each category have many services. This compute have EC2, light sail, many services, okay. So in short, there are hundreds and hundreds of services provided by AWS. But it's not possible for anyone to learn or use all of these services, right? That's why now let's come back to the slide, and here I will list top 25 AWS services that are the most important and used 80% of the time in your application. You can build 80% of the application by using this just 20% services. First category is compute service. Second category is database. Inside this we have the main services also I have written here. Then we have storage, then we have networking and content delivery category, next messaging and integration, and the security services, and the last one is the infra and DevOps services. 80 to 90% of the application only need these services I have written here. So for example, if you are a developer, then you need to host your application, you can use this EC2, or you can use the Elastic Beanstalk or Lambda or ECS, okay. If you want a database, you can use RDS. So I will explain all of these services one by one in upcoming questions so that you do not have any confusion in these services at least. And most importantly, I will explain when to use which type of services, when to use EC2, when to use Elastic Beanstalk for hosting the application, okay. So based on the situation it is required. Now that is the important thing, and these services we are going to learn in the application question. We are going to learn in the upcoming question, and let's move on. What is hybrid cloud? Let me give you a very simple example. Imagine you have a very old e-commerce application. Now your company has migrated application in on-premise, okay. Now your company has migrated the application to the AWS cloud with a front end and back end servers, something hosted in the EC2 instances of the AWS like this. and the user is accessing the application from the front end server. Okay, but there is one problem. Although you have migrated the application servers, but your company could not migrate the database server, which is still present in your company office or on premise or data center, something like this. Okay, so it is separate and isolated inside your office. The reason for not migrating this database can be anything. Maybe your company does not yet fully trust the AWS for critical data. Okay, your company has some banking information, something very they want to be keep with them only, or maybe your data is very large and it is very complex to migrate all at once. Any reason for not migrating the database. Now in this situation you can use the hybrid cloud model. For that you can use AWS Direct Connect or AWS VPN to securely connect your AWS hosted application to the with your on-premise database, like something like this. Okay, so that is the hybrid approach, meaning half cloud and half on-premise. Clear? And here is the simple and easy to remember definition. Hybrid cloud means combining on-premise infrastructure like your own data center or server with AWS cloud services, so they work together. This definition in the book will help you in revising the concept. What is a resource in AWS? What is the difference between a resource and a service? Yeah, I know it sounds very easy, but I don't want to take any chance with any confusion. So let's quickly understand it. Let's go to my AWS Management Console. Here it is. Here, for example, to host your application, you need EC2 instance. So here is EC2 instance. Let's press it, and here it is. Now you will find the launch instance option for EC2. Now listen carefully. When I press launch instance, that means an instance of the EC2 service will be created in my AWS account. Okay, that specific instance we call a resource. So basically, after creating the resource, I can use it for any purpose in the cloud. For example, I can host my application inside that EC2 instance, and in the same way I can create multiple resources in my AWS account for different services also, like RDS instance for database, S3 instance for storage, Lambda instance for serverless function. So that's how. Now let's go back to the slide. For example, this is your AWS cloud, and there are many services available here like this Elastic Beanstalk. Okay, now your company AWS developer can use any of these services by creating instances of them like this. Okay, and those created instances in your company account are called resources. Okay, and you can name them as per your convenience. So if you are a developer, just understand it like AWS service is like a class and AWS resource is like an object or instance of that class. Great. Now you are 100% sure what is a service, what is a resource, what is the difference. Here is the easy to remember definition. AWS service is a tool or feature offered by the AWS to perform tasks like computing, storage, network security. AWS resource is an instance of that service that you create, configure and use in the cloud. For example, AWS service is like a class, AWS resource is like an object or instance of that class. Okay, now this simple diagram and theory in this book will help you in the quick revision for your interviews. Now for a single application hosting, you have to create many resources. Now, how to manage those resources, that I will cover in the upcoming questions. What are AWS regions and availability zones? How they are different? From the name itself, you can understand region means some physical location. So for example, here is the world map and it shows the region. These dots shows the regions or the geographical locations where AWS has multiple data centers. So all these dots, blue dots, are the regions. Okay. Now, as I mentioned earlier, your company do not need to maintain physical servers in its offices. No on-premise services, right? Instead, your company can simply subscribe to and use cloud resources from AWS via internet. And your company have to choose the AWS region, which location is closer to your company, so that the users of your company can get faster access. Okay, here is the definition. AWS region is a geographical area where AWS has multiple data centers. Now, what is availability zones? Within a single AWS regions, there can be multiple physical separate data centers. These are called availability zones. Remember, AWS regions means AWS services are fully available in a location. For example, in Mumbai, in North Virginia, Singapore, these are the regions. But the actual physical data center location within each region are the availability zones. So there are multiple data center present inside one region. That is possible, because if tomorrow one data center is failed, then other data center will immediately provide the backup, right? Here is the definition. AWS availability zone is a physically separate data center within a AWS region. It ensures high availability by protecting your application from failure in a single data center, and that's the answer to this question. What are AWS Compute Services? Name a few of them. Now listen very carefully to the answer. The answer is AWS service that do computations are called compute services. Let me explain it. Okay. See, compute services are those services that handle computations. Computations means processing or executing your application logic. Like you have processor in your computer to process programs. Same way. For example, here are some AWS Compute Services, popular one. So Amazon EC2 Elastic Compute Cloud is an AWS Compute Service because you can use it as a server to host and process and execute your applications. Okay. Then AWS Lambda is used for serverless computation. Then AWS Elastic Beanstalk is also used for deploying applications without managing infrastructure. And then EC2 auto scaling is there for, used for scaling the EC2 instances automatically. Now don't worry, I will explain this in detail in upcoming question. But for now, just understand that these services are used for computation, processing, and that's why they are called AWS Compute Services. Okay, here is the final definition. AWS Compute Services provide cloud-based processing power, auto scaling, and execution environments for applications. That's it. Now in the upcoming question, we will understand the first and very important compute service, and that is EC2 in detail. What are Amazon EC2 instances? When would you use them in a project? To be very short and simple, EC2 are just like the servers where you host your application. Here is a very simple diagram. You have hosted one application, which is front end is hosted on this physical server. Okay, and back end or API server is hosted on this separate physical server. Similarly, this is on-premise application. Similarly, in the AWS cloud, we call these servers as the EC2 instances like this. EC2 stands for Elastic Compute Cloud. In short, mostly we use EC2 instance to host application. But like you can use the server for many other purposes, similarly you can also use EC2 instances also for many other purposes like running the background processes and others. It's just like a CPU. Here is the simple and easy to remember definition. EC2 instances are cloud-based virtual servers that allows to run application without needing to buy or manage physical hardware. That's it. Now you may ask, is EC2 is the best and the simplest and the fastest for hosting application? The answer is no. So which one is the best for hosting application? That I will share in the upcoming question. What are the differences between horizontal and vertical scaling? When to use what? Both of these concepts are closely related to EC2 instance in the cloud. Let's take a simple example. Suppose you have the EC2 instance and your application is hosted over there. Now, after some time, due to heavy traffic, your website starts getting overloaded. Now you need more EC2 instances to handle the traffic. Otherwise, this single EC2 instance will be overloaded and crashed, right? For that, you can add more EC2 instances like this, and then the incoming traffic is automatically distributed equally among these EC2 instances using a load balancer. So this concept is called horizontal scaling or scaling out. Load balancer I will explain later in detail. Now the other option is vertical scaling. Okay, in vertical scaling, instead of adding more EC2 instances, you increase the power of the existing and single one EC2 instance. For example, you can add more CPU, more RAM, more storage to the same EC2 instance. Okay, like this. So you are making the EC2 instance bigger. Okay, so that is vertical scaling. Here are the differences between them. In horizontal scaling, you add more EC2 instances. In vertical scaling, you are increasing the size of single EC2 instance. So now the real interview question is, when to use what? Here is the answer. Horizontal scaling is best for stateless applications like microservices, web APIs, and distributed systems. Whereas vertical scaling is preferred for stateful application or monolithic application. Okay, because hosting stateful monolithic apps in separate EC2 instances is not possible. So, and yes, there is one more difference, and that is horizontal scaling in AWS is more cost effective as auto scaling is possible using auto scaling groups, and load balancer is possible in horizontal scaling, whereas vertical scaling is expensive and it is limited. You cannot increase the size of an EC2 instance as much as possible, right? It has a limit to increase the size of a single EC2 instance, right? In short, horizontal scaling and microservices architecture is better. That's it. All these differences are written clearly here in the book so that you can later easily revise. Now you may ask one question. What is this auto scaling groups? Okay, so don't worry, that I will explain in the upcoming question. What are AWS auto scaling groups or EC2 auto scaling? Now I have already explained the concept of horizontal scaling. Here, if your website is hosted in the AWS cloud and if the traffic increases, then you can handle the load By adding EC2 instances manually more. Okay, you can add any number of instances EC2. But here is the problem. What if someone forgets to add the EC2 instances during high traffic? Then the application will crash, right? Or if the traffic is very low but no one removes the extra EC2 instance, then you have to pay the unnecessary cost of that extra EC2 instance, right? Because that server is idle, but it is still running. So as a better solution, instead of manually adding or removing EC2 instance, you should use the auto scaling group ASG service in AWS. Okay, so it is better to, because it will automatically, there is no manual thing. If the traffic will increase, it will automatically increase the EC2 instance. So in your in AWS account, you do not have to add EC2 instance. You better add Amazon EC2 auto scaling. Okay, here is the definition. An auto scaling group service is a set of EC2 instances that automatically scale based on traffic or custom rules which you can set. Okay, now initially, as I said, your this ASG auto scaling group will have just one EC2 instance and initially, but when the traffic increases, it will automatically keep on adding, or if it is not required, traffic is less, goes down, the extra EC2 instance will be automatically removed also. In short, you do not need to manually create or delete EC2 instance. That is not your headache now. AWS take cares all of it for you, and that is the beauty of auto scaling groups. That's it. Here is a short question. What are EC2 instance types? Now this is not a very important question, but based on your need, you can create different types of EC2 instance in AWS. So here is the table. Don't try to memorize it. Just be aware that there are many types, and the most famous one is this T family, which because it is a very general purpose and it is low cost also. Most organization use this if they are new in AWS. If you are not sure, then go for this T family. Okay, and yes, don't try to memorize it, just you have to know that there is a T family which you have to use for EC2 instance types, and there are other families, but not so important they are. Okay, what are on-demand, reserved and spot instances? Now again, this is related how you want to buy or subscribe AWS services. For example, you can subscribe EC2 instance based on demand, meaning pay only for when you use EC2 instance, otherwise not. Only pay, no commitment required. Whatever you use, pay for that. Like you hire a cab to go somewhere and pay for the travel duration only. Okay, same way. This is on demand EC2 instance, and that is ideal for short term or unpredictable workloads. Okay, second is reserved instance, meaning, for example, you pre-book a server for 1 to 3 years and save money. The reserved EC2 instance is best for steady and long-term use. Like you hire a car for 6 months period. So for that, one-time payment is high, but if you are using it continuously, then the ultimate cost will be low, right? So that is the reserved instance. Last one is the spot instance. So meaning buy unused capacity at huge discount, but this can be interrupted anytime. For example, you booked a shared cab for your travel, which is very low cost, but it can increase your travel time and have some other problems also because of other travelers in your shared cab, right? So this spot instance is great for flexibility or batch jobs which are not active batch jobs, background jobs. Okay, because they will happen in the background, so even if they are interrupted, still it is okay, right? So great, that is the answer to this question. And in the upcoming question, we will explore one of the most used service in AWS, which is very, very important. I will explain in upcoming question. What is AWS Elastic Beanstalk? For what purpose can you use it? If you are from a development background, then this is one of the top AWS service you will use. Now, if you remember IaaS, which stands for Infrastructure as a Service, then EC2 is the example of IaaS, meaning if you are using EC2, then you are using IaaS model of cloud. Because to host application, you will also take care of many things which are in IaaS only. Okay, so EC2, you have to manage many things. You have to install the operating system, you have to, for application hosting, you have to install the frameworks to host your application, many things. But there is, if you remember, PaaS, which stands for Platform as a Service, then is this model. As a developer, you only need to provide the application code, data, configuration, and nothing else. For this, you do not have to create the EC2 instance or configure load balancer or manage the underlying this infrastructure. Okay, all of them automatically handled by AWS. You just need to create your web app, API, or backend service, front end, and deploy it using the Elastic Beanstalk. That's it. So whether you are building a web app, a REST API, mobile backend, you can use Elastic Beanstalk of the service of the AWS. Okay, and EBS lets you deploy your application in the cloud with few clicks only. It's the simplest way to deploy or host your application in AWS cloud. Here is the simple and easy to remember definition. AWS Beanstalk is a fully managed platform as a service that enable developers to deploy and scale also web application and services without managing the infrastructure. Okay, so simple definition like this will help you to revise easily from the book before your interview, so that you don't forget the answers. Now you may ask, if Beanstalk is the right choice, the best choice, simplest choice for a hosting application, then why we have EC2? Good question. So that I will explain in the upcoming question. But yes, before that I will explain some features of Beanstalk so that you can easily understand Beanstalk in a very complete way, and you will know that why Beanstalk is so popular. It is very popularly used. Before moving forward, a quick note here. I created a complete AWS interview preparation bootcamp for you with 3 powerful tools. Number 3, 200 plus AWS interview questions from all the topics step by step, even for AWS beginners like this. Second, a PDF book for quick last minute revision. And first, 10 AWS mock interviews to practice like real interviews. Many students have already cracked interviews with my courses. All links are in the description. If interested, great. If not, no worries. Let's move to the next question. What are the 5 main features or advantages of using Elastic Beanstalk? Now by the end, you will be 100% confident on Beanstalk. So I already explained previously how EBS is the PaaS, okay, service like this. Now to deploy an application in AWS, you have 2 choices. Either you can use EC2 instance and manually set up your application environment, or second is use Elastic Beanstalk, which simplifies everything. How it simplifies, why it's a great choice? Because of Beanstalk 5 features. First feature is it supports multiple programming languages like .NET, Java, Python, Node, PHP, Ruby, Go. So no matter which tech stack you are using in your application, Beanstalk can handle it automatically. You don't have to install those frameworks in your AWS environments. Okay, it has automatic everything. Second feature is built-in auto scalability, meaning when traffic increases or decreases, Beanstalk will automatically adds or removes instances behind the scene. You do not have to worry about anything manually. You do not have to, nothing is required basically. Okay, very important feature is. Third feature of Beanstalk is fully managed environment. That means AWS handles everything: OS updates, security, maintenance, everything, patching, monitoring, everything. So you just have to focus on writing and deploying your code on your first you're writing your code and then deploying it in few seconds with the help of Beanstalk. Fourth feature, high availability. Elastic Beanstalk is integrated with load balancers behind the scenes and auto recovery. So even if one server fails, but your app will be keep running. You do not have to worry about that. Okay, automatic load balancing. And last feature is secure and compliant. Beanstalk can integrate with IAM roles, VPC, AWS Certificate Manager, everything. So your application is secured and follows AWS best practices for authentication and data protection. In short, every tool and best practices is already there. You have to deploy your code using Beanstalk. Okay, so that's the answer to this question. Now you may ask, if Beanstalk is so good, then why we need EC2? Sometimes we need EC2 also for hosting applications. So when it is the case, and that I will explain in upcoming question. What is AWS Lambda Function? Have you ever used them in your project? Very important question from interview point of view. Stay with me till the end and then you can explain this to anyone with example. Let's understand with the help of an example. Suppose you are a developer and your development team has created a web application in AWS. You have the front-end server built in Angular, React or JS. This front-end passes the request to the backend or API server, which can be in .NET, Java or Node. And finally, everything connects to the database. Okay, so this front end and back end can be hosted in EC2 instances or hosted in using the Elastic Beanstalk. So that doesn't matter. Okay, can be in anything. Now imagine a user is signing up in your application like this. And during the sign up, the user is uploading a photo or any kind of image document. That image document will be stored in the Amazon S3 storage like this in AWS cloud. Okay, S3 is used to store mainly the images. Okay, and I will explain in detail in upcoming question about this S3. But now you know it is in short used to store the files and images of your application. Okay, now listen carefully. Images are very large in size and or maybe videos very large in size, and large image require more space in S3, which means more AWS cost for your company because you are storing bigger files in S3. Okay, now as an AWS developer, you come up with a brilliant idea or a solution to save cost of your company. You used a service in AWS called AWS Lambda. You created a Lambda and inside that Lambda you will write some code to compress the images. Okay, now what happens whenever the image is uploaded in this Amazon S3 storage bucket or account or storage, then a trigger will be fired and automatically your Lambda function and the code inside it will be executed and will compress the image, and then it will store the image. Getting my point? Before storing the image will be compressed in size by your code which is written inside the Lambda function. That means now you need less storage is required in the S3 storage, and your company cost will be saved, and that's a great job, and you will get the Employee of the Month award for saving company cost. So this is a very common use case, and if you will say this in the interview, then interviewer will think that you have read it somewhere. Okay, so here is one more example. Suppose you want that as soon as a user signs in like this, a successful welcome email should be sent to the user automatically back to him. No manual thing, automatically. For this also you can write a Lambda function which will be automatically triggered as soon as a user will sign up, and the Lambda function will send the welcome email to the user. That's it. Remember, Lambda function is just a piece of code which is running behind background. Okay. Now I'm sure you are fully understood the purpose of AWS Lambda, right? And here is the simple, easy to remember definition. AWS Lambda is a serverless compute service that lets you run code in response to events. When something will happen, then your Lambda function will be triggered. Okay, some event must happen to trigger the Lambda function without managing servers. Basically, without managing servers, what is the meaning of this? That I will explain you in the upcoming question in detail. Okay, so remember, in short, Lambda function will only execute when something will happen and it is a piece of code. Alright, if this is fully clear to you, then write crystal clear in the comments or chat. That will boost your confidence and help you to never forget this concept ever in your life. Also, this diagram and this definition in the book will help you in quick revision for your interviews from the book later. Okay. Now in interview, sometimes they ask one indirect question. Okay, this is the first question. Now they will ask, why not just write the Lambda function code directly inside the main application itself? Lambda function is just a piece of code. Why not to write inside the main application this same code? And that's a great question, and I will answer that in the upcoming question. What exactly is serverless in AWS? Is it truly serverless? Now you are going to master this serverless. So I already explained this use case of AWS Lambda in the previous question. And the biggest advantage of Lambda is it is serverless. Now listen carefully. Serverless doesn't mean that there are no servers. Lambda functions runs on some AWS server only. But it is called serverless means because you do not have to manage that server on which Lambda function is running. Okay, you will pay only for how many times your Lambda function is executed, not for the server uptime. Getting my point? So you do not have to worry about anything about that server, like setting it up, maintaining, or anything. And also remember that your main application might be running on EC2 or Beanstalk, but Lambda functions run separately and independently on some separate server which you do not have to manage. Okay, so now you may ask, what is the advantage of being serverless? So in AWS, this Lambda case, Lambda function allows you to separate or decouple some piece of logic from your main application which you already know, and that is the benefit of the serverless. It's a big benefit. Okay, so let me give you an example. See, nowadays everything is moving towards decoupling and loose coupling. For example, earlier we have that big monolithic applications where front end, back end, logic, HTML, Java, JavaScript, everything was inside one big application, right? And we call them monolithic applications. Now we are moving towards microservices. Small piece of independent services, which are loosely coupled, which are not dependent on each other. So that is the benefit of serverless, being independent. So because as compared to a big tightly coupled application, a monolithic application where you will do one change and you have to test all the big application, that's a great risk. So these small services are important, and AWS Lambda will help you for doing the same, for decoupling the logic from your main app. Okay. Whatever logic can be run independently, like image compression, email notification, data cleanup, you can put that code inside Lambda. So that is the main reason behind the existence of the AWS Lambda. And the same is the importance of serverless and independent services, and same for microservices. All clear? Now here is the simple short answer. Serverless in Azure means running code without managing the server. And the second part, is it truly serverless? No, it's not. Servers still exist, but you don't manage them. Okay, so that is the answer. Now you will ask, AWS Lambda is triggered by events, right? So what are those triggers? What types are of those triggers? And that I will explain you in the upcoming question. What is Amazon RDS? How is it different from the regular databases? Now, if you remember this PaaS category, then for applications, you can host the application in EC2 or Beanstalk or Lambda in AWS, right? Similarly, for data, you can use RDS for data, RDS. Okay, here is one more very important diagram where you can see our applications are getting the data from the RDS, which is the database. Okay, now as a developer, if you have used MySQL, Oracle, SQL Server, etc. on your local system or in the on-premise servers, then Amazon RDS is the same and the best RDBMS database in AWS for you. You can use it along with the Oracle or MySQL or any database. Okay, so for database of your if you want database for your application, select the RDS service in AWS. Here is the clear and short definition. Amazon RDS is a fully managed cloud-based relational database service from AWS. It is offered as a platform as a service, meaning you just have to provide the data table structure, whatever, but you do not have to install the Oracle, or you do not have to worry about the main installations. Just you have to provide the data to AWS and they will already use RDS. You have just to choose the RDS service. Okay, AWS will take care of for managing the backups, for patching, updates, everything AWS will do. That's the diagram and that's the definition, and this definition diagram will help you in the revision for your interviews from this book. What is virtual private cloud VPC in AWS? Why do we need it? By the end, you will understand this 100%. Imagine your company is hosting all its applications using EC2 instances like this, and databases, resources on the AWS servers, something like this. Okay, everything I explained in the previous questions. All these resources are used by your company. Now your company wants all these resources must be secured, meaning they should not be directly open to the internet. and only the internal resources or the approved users should be able to access these resources. Okay, all these resources, because if they are open to internet, then anyone from the outside can access EC2 directly and can steal your data, can access your RDS. So we don't want that, right? To avoid this, AWS gives you something called a VPC, which stands for Virtual Private Cloud. VPC is like your company's own private network inside the AWS cloud. Once your company server databases, other sites are inside the VPC, then they can talk to each other. That's fine. But they are not exposed to the internet by default. Got it? So here is the final and simple answer. A virtual private cloud is a private network in AWS where you can place your cloud resources like EC2 instances, database, anything. And yes, AWS automatically creates this VPC, default VPC for each region. You don't have to worry about this, okay? But yes, you can also create your own VPC and you can customize it, but AWS also provide you by default. Now you will ask if so that's point I have written you here, that AWS automatically creates a default VPC. Now you might ask, if VPC by default blocks internet access, then how your web applications which are hosted here or in Beanstalk are accessible to users from outside via the internet, right? Great question. So I will explain that in the upcoming question, but with this diagram and this definition, later you can easily revise for your interviews from this book, right? What is the role of AWS Elastic Load Balancer? What are the types of load balancers? Now you are going to master this concept. Let's say you are a developer and you set up AWS Cloud for your company, and then you are running your applications in EC2 servers, like the front end on EC2, API, and the database like this. So as I explained earlier, when more users will visit your website, more and more, so you will add more EC2 instances like this by using this horizontal scaling concepts, which I already explained in previous questions, right? Now here is the real question. How the incoming traffic from multiple users like this on the internet will be shared equally between these EC2 servers? How it is shared? Okay, for that we will use AWS Elastic Load Balancer. AWS Elastic Balancer will act like a traffic police or a traffic light. First it will receive all the requests, and then it will evenly distributes all the requests properly, equally between the multiple EC2 instances like this. Okay, it will make sure that no EC2 instance will be overloaded. Okay, it will distribute the requests properly. Here the simple, easy to remember definition. AWS Load Balancer distributes incoming traffic across multiple EC2 instances to ensure high availability, scalability, and fault tolerance. Clear? Now there are 4 types of Elastic Load Balancers, and this one which I showed you right now is called the Network Load Balancer. It is a type of Elastic Load Balancer. Okay, and here are the other types. We have the Network Load Balancer, then we have the Application Load Balancer, Classic Load Balancer, and Gateway Load Balancer. So all these load balancers I will explain you in the upcoming questions, but this diagram and this definition, these types from the book will help you in revision later, right? So as I said, we have to distribute. The load balancer is primary for distributing the requests properly. Okay. What is AWS Route 53? How does it manage global traffic? Let's understand this 100%. Imagine you are working as a lead developer in a very big company like Amazon or Microsoft, and your application is hosted globally in the AWS cloud. Okay, for example, here you have one set of EC2 instances like this in region 1 New York or any region, okay, and another set of EC2 instances are in Mumbai. Okay, similarly, you have users who are accessing your applications from USA, and there are some users which are accessing your applications from India. Now you want that when the users are sending requests from near USA users, those should be redirected to New York region like this, because New York region is close to USA users and they will get the response faster, right? For that, you can use Amazon Route 53 service like this. Route 53 will receive all the requests and distribute the request based on the closest region. So here when users from India will or near India will send the request, they will be redirected to the Mumbai region. So AWS Route 53 distributes user traffic based on the location so that users request goes to the nearest region and response is faster. That is the role of Route 53. But yes, one more thing. Once the request will reach this New York or Mumbai region, here you can set up the load balancers. It is possible inside those regions, and then you can equally distribute the request between the multiple EC2 instances. Okay, so that is the full picture and real use case of Route 53 in real projects. And here is the simple definition. Route 53 is a DNS-based traffic routing service that distributes user requests across AWS regions based on rules like user locations or latency. So, what is the meaning of latency? Location, you understand. Latency, what is the meaning of latency? Latency, for example, if region 1, this New York region, suppose it is down or it is slow for some time, then Route 53 will redirect the USA users also to the Mumbai region, to the region 2, because region 1 New York is down. That also Route 53 will manage, and that is the answer to this latency. Okay, so this diagram and definition will help you in revising the concept quickly from this book. Now in the upcoming question, I will show you what is subnet, which is like the kid or son of the VPC only. What is AWS IAM? Identity and Access Management. Be ready. After listening to this answer, you will be 100% confident on this concept. Let's understand with the help of an example. Suppose your company is using AWS Cloud and there are two applications hosted inside it. One is a email application and another one is the payroll application. You are the developer or architect managing this AWS setup for your company. Okay. Now there are 3 users trying to access these apps. So first is a regular employee, user A, regular employee of your company. Second, user B is someone who is the HR of your company. Okay, he is also an employee. And third is the user C, which is outside from your company, not the employee of your company. Okay, now listen carefully. As a AWS developer, you will take the help of AWS IAM. Okay, Identity and Access Management. You will set up this service in your AWS account to decide who can access which application. For example, the email application here, okay, both the user A and user B, company employee and company HR, will be able to access, but the user C is unauthorized, he will not be able to access this email application. Okay. Similarly, for the payroll application, only and only the user B, only the HR will be able to access, not even user A, because payroll will be accessed by, or distributor pay will be distributed by HR only, right? So that is how IAM works. It authenticates user to check who they are and authorize them to give permission what they can access. Okay, so basically IAM implement authentication and authorization concepts. Remember this. And yes, if you are confused between authentication and authorization, don't worry, I will explain this in upcoming question. But before that, here is the simple definition. AWS IAM is a secure cloud-based service in AWS that helps organizations verify users and control access to AWS services and resources. So whatever services are present in your AWS, IAM will control the access for them. Okay, so in short, IAM will not allow unauthorized users to access your AWS applications. That's it, and this diagram and this definition in this book will help you in doing the quick revision before your interviews. What is a CI/CD pipeline in AWS? How you have used in your project? Now, if you have some experience as a developer, then you already know these steps involved in creating an application. First, you plan, then code, build, test, release, deploy, and then finally operate or monitor the application in production. So that is the normal application lifecycle. Now, what is CI? CI means continuous integration. It simply means, let's say you are a developer and you write some code for a new feature. You push your code to some shared place like GitHub or AWS code commit. So at the same time, your teammates are also writing and pushing their code, right? So here comes this integration process, continuous integration. As soon as you push the code, an automatic process start, which is by a tool called AWS Code Build. First, it will check whether your code will build properly, no compile time error. When build is successful, this build point. When build is successful, it automatically runs the unit tests. Okay, if it passes all the tests, then only your code will be accepted and added to the main branch of your project. Okay, so that is the continuous integration, because you are continuously pushing code every day to the main branch. Okay, so that process is automatic. That's why its name is continuous integration. You also keep working on new items in parallel and continuously pushing the code for integration, right? And yes, as I said, if there is any build error or any test will fail, first you have to fix those, and then only your code will be merged to the main branch. Now second point comes CD. What is continuous deployment? It means the code from the main Git branch is automatically deployed to different environments like dev, QA or staging using a tool like AWS Code Deploy or AWS Code Pipeline. Okay, so it's like this. So the continuous code is coming, you are pushing the code, and that pushed code is released, deploy, operate again and again in a cycle like this. That's why its name is continuous deployment, because from the source code is continuously deployed by the infra or DevOps team in the production or QA servers, whatever servers. And of course, before pushing to production, you can add manual approvals from the QA team, manager or other gates in the pipeline. In short, CI/CD pipeline in AWS helps to automate your entire project flow like this, from coding in development to production, making everything faster and smoother and simpler. Okay, That's the answer to this question. And finally, here is the definition. A CI/CD pipeline is an automated process used by developers and DevOps teams to build, test, and deploy code quickly and reliably. Now you will ask, what are the tools used by AWS team to perform these steps of CI/CD pipelines? And that I will cover in upcoming question. What is Amazon CloudWatch? How does it help developers? After hearing this, you can explain this concept to anyone. Let's say you are a developer and you have developed your application and deployed it to the production environment in AWS. Now user will start using your application. But as a developer, you want to keep an eye on how the application is performing. For example, are users facing any errors, or is the app sometimes slowing down or having any latency issues? When exactly the app is slowing down? Or what features of your applications are being used the most by the users? So to monitor all these in one place, AWS gives you this powerful tool called Amazon CloudWatch. Okay, CloudWatch mainly provides two things to you. One is matrix and one is log. This is the diagram. Matrix will basically show you the performance numbers, like how much is the CPU usage by your application, how much is the memory usage of your application, or how many requests your application is receiving, basically request count. So all these performance numbers. In short, matrix is all about numbers, so that later by checking these numbers you can analyze the overall performance of your application. Second thing after matrix is logs. Logs, if you are a developer, you already know log is like what actually happening behind the scenes. For example, if a user has encountered some error while using your application, then that error will be logged with the information. And by the help of the CloudWatch, as a developer, you can see that error message and in a very good way. And for that, CloudWatch will provide you many tools. Okay, then you can fix that problem error, and then you can deploy the new solution. Also, CloudWatch does not just show you the data or just display the data. It also help you to take the actions also. For example, you can use the these are the features. You can use the CloudWatch alarms to get the automatic alerts when something goes wrong. For example, if sometime your application is taking high CPU usage or spike, then that's an error. Then CloudWatch can send you the alerts or alarms like in email. Or if user encountered any error, then also CloudWatch can send you the email. Okay. So there are many more features of CloudWatch, like CloudWatch dashboards, then which will show you the key metrics visually on a screen. Then you can use the CloudWatch logs insights to search and analyze logs quickly using very simple queries. Then you can also connect CloudWatch with other tools like Amazon QuickSight to generate reports and make smarter business or technical decision. You can take decision based on those reports. In short, CloudWatch and its tools help developers monitor, troubleshoot, and improve application performance, and that is all in the real time. That's it. Finally, here is the definition of CloudWatch. CloudWatch is a monitoring service that collects, analyzes, and visualizes the performance, the data, logs, and metrics from your AWS application and infrastructure. That is the answer to this question, and now you will never forget this. But yes, in case you forget, then this definition and diagram in the book will help you in quick revision. Now, the CloudWatch is like a big container, and it has many tools inside it which helps developers in analyzing the application. One of the popular tool is Amazon CloudWatch Application Insight, and that I will explain in upcoming question. Great job, my friend. Most will just talk, but the way you finished this video shows your seriousness and dedication towards your goal. Now, if you understand these questions, then there are slightly more complex questions also, like SQS and SNS, CloudFront, DLQ, and others which are also very important and asked in interviews. All I have explained in my complete AWS interview bootcamp. Many of my students have already used my courses to crack their interviews. Now, if you don't want to miss a single question for your next interview, then check out the bootcamp and book link in the description below.